My name is Jay. I work for eBay. That's my Twitter ID. You can find more information about me. So today I'm going to cover various use cases where we use Cassandra at eBay. I'll have lots of slides and lots of material, so please save your questions till end. So let's start with some numbers. So at eBay, we have more than 100 million users, sellers, and buyers worldwide. We have more than 400 million items for sale across 40 to 50,000 categories. We get billions of page views per day, billions of SQLs per day. We have thousands of servers deployed in multiple data centers, and everything is always available, always online. So it's a huge scale at which we operate. So eBay site data infrastructure, it's not this. So we don't try to fit big camels in small cars. There is a rope around the mouth of a camel, otherwise it would be like really crazy. So it's really a mixture of multiple SQL and NoSQL databases, and we use the right database for the right problem. So it's really a heterogeneous mixture of all these databases. So most of our critical use cases are still deployed in Oracle. We have thousands of Oracle nodes, more than 2,000 sharded logical hosts, more than 16,000 tables and 27,000 indexes. We get more than 150 billion SQLs per day, including replicated SQLs. And more than 5 petabytes of storage is provisioned. We also use MySQL for some low traffic and low criticality use cases. We also use the MySQL in-memory engine as a caching tier for some use cases. So from last 2 to 3 years, we are evaluating various NoSQL databases, and now we have Cassandra, MongoDB, XMP, and Hadoop HBase in our NoSQL family. Our Cassandra deployment is more than 10 clusters with total of more than 100 nodes spanning across multiple data centers. More than 250 terabytes is provisioned. We use both local hard drive as well as shared SSDs. We have more than 9 billion writes per day and more than 5 billion reads per day. We also use MongoDB. So a little bit where Cassandra and MongoDB fits. So Cassandra is really good fit for use cases where we have lots of writes and lots of storage need. And now we are also putting some use cases with lots of heavy reads. Versus MongoDB is a really good fit when we have low storage need, which can fit everything in memory, and we have lots of reads and maybe low volume of writes. So XMP is an in-memory, highly transactional database from a company called MuSeries, and we are replacing MySQL in-memory cache with XMP. We also use Hadoop and HBase. So Hadoop is more on analytics side, and our new search infrastructure is using Hadoop for building search indexes. And we use HBase in that Hadoop environment to bring our incremental updates for the item from site Oracle database into Hadoop environment. So how do we scale our relational databases? So definitely we shard our databases, and we use pretty much all standard patterns like modulars, lookup-based sharding, or range-based sharding. An interesting thing is our application never sees a physical database. Our application always deals with logical database, and that gives great flexibility for DBAs. We can easily move our physical database from one box to other box, or we can consolidate multiple databases on one box, or even split it out. We definitely replicate for disaster recovery, readability, and scalability. And the scale at which we operate, we cannot use transaction, we cannot use joins, and there are no referential integrities. So it's pretty much like NoSQL. So why Cassandra? So all our databases are deployed in multiple data centers, and we always got to be ready for disaster recovery. And we really love Cassandra's multi-data center support, which is active-active. And what I mean by active-active is multiple data center can take read as well as write. That gives us a local latency. Cassandra is always available, no single point of failure. It's a great story out there in Cassandra, peer-to-peer architecture. We can easily scale up Cassandra and scale down, and it fits really nicely with our cloud environment. We have really fantastic write performance of Cassandra. we use distributed counters and Hadoop support for some real-time analytics. But we are not replacing our relational databases, but we are complementing with this NoSQL. So some use cases where we have sparse data, big data, we want to do real-time analytics, and flexible schema like key value pairs, really relational database is not a good fit. And many use cases don't need a top-tier setup like very costly SAN and even Oracle. So this diagram shows a workload and a traffic pattern in our Cassandra cluster. So we started sometime in late 2011, and we were on one use case at the time, and after a year, we have many use cases worked on. We have exponential growth in writes and asynchronous read, and kind of linear growth for storage. Until now, we were not putting many read-heavy use cases on Cassandra because of read were not as great. But now it is changing because of level compaction, so many optimization done, other companies working on that. So we are putting more read-heavy use cases as well on Cassandra. So use cases on Cassandra. So we have various time series use cases where we do real-time insight and also take real-time action based on that. So fraud detection and prevention. So we keep track of your activity on site, such as how many labels you are printing per day, and use this information to detect fraud and even prevent fraud. Quality click pricing for affiliates. So we have various affiliates and publishers. They send traffic to our site, and we use Cassandra to segment this traffic and segment users and feed this information to compute the pricing for our affiliate. So for example, if affiliate sends us a brand new user and he ends up buying something from eBay, it's a really valuable traffic, versus if affiliate sends us some users who are already frequent buyer of eBay. We use it for order and shipment tracking and insights on that. Mobile notification and logging. So whenever we send out notification on a mobile device, we track that information in Cassandra. Our cloud environment is using Cassandra to keep history of the configuration changes. Red Laser is our sister company, and we collect server metrics from the production servers and transfer to the Flume and send it to the Cassandra for deep analysis. So these are more of a kind of a business side, but we also collect production server metrics like CPU, hard disk, and so on. That information is used for monitoring and alerting. We use Cassandra to store a test graph of eBay users and item and use it for some near real-time recommendation. Personalization data service. So we keep track of your activities in session and use this information to show you some personalized pages on site. Personalization data service is actually there for quite some time, and it is serving as a server-side cookie management platform at eBay. Social signals on eBay product and item pages. If you have noticed like, own, and want buttons on eBay item pages, that is served by Cassandra. So we are considering Milo's item and stored inventory to put it in Cassandra. This is still in the evaluation phase. By the way, all these use cases are not deployed in production yet. Some use cases are deployed and some are still in development. So I'll go through each of the use cases one by one and a little bit more about the system overview and the data model. So the first is real-time insights on the time series data and the actions based on that. So as I mentioned, we don't just do it for reporting. We use this data in real time to take some actions like fraud prevention and other things. So at eBay, we have various systems like checkout, payment, shipping, refund, recoup, and each of these systems generate like publish message to a central bus called a business event stream. This is a homegrown message-oriented middleware at eBay. And there are various applications which read this published event from this business event stream and write to Cassandra in a raw format. As well as we do simple in-memory aggregations, even sometimes do complex event processing, or just use Cassandra distributed counters to do some pre-aggregations and then write it to Cassandra. So as you can see, this data is pre-aggregated, pre-processed, and then returned to Cassandra. So it's not a late analytics. Everything is done upfront. So for example, label printed per day per user, user segmentation for affiliate pricing, orders per hour, and other things. And this information is kept for several months to years. And this information from Cassandra cluster is used by these various use cases like fraud detection and affiliate pricing and other things. So for example, we keep track of your label printed per day per user and use this information to detect the fraud, because it may happen that we see that your label printing activity is steady on like say 50 labels per day, and suddenly if it increases like 1,000 labels per day, that indicates some suspicious activity. So it may happen that fraudster may have took over your account and is starting printing a lot of labels and then go and sell it to the black market. So quick glimpse on data model. So the user ID is a row key here, and column name is a composite column name. First part is the date, and the second part is a career type. And the column value is dollar amount or the number of label printed. So as you can see here, this is a wide row, and we keep historic data as well as we get this data in real time. And this can be used to detect some abnormal activity on site. Similarly, we have this user transaction and segmentation. Again, the row key is user ID, and the column name is a composite of date and bucket. Bucket is basically different buckets we segment the user. These users are sent from affiliate sites to eBay, and then we decide whether the user sent to eBay is really a big value to eBay or not. And here we also store the actual transaction and the payload as a column value. So a little bit more on the data model. So raw event data, as you can see, it's stored as so row key is hour and the event type like checkout, buy, bid. And actual payload is stored for each timestamp. So time UID is basically timestamp, which is unique. And each rollups are stored in different column families like rollups per minute, rollups per hour. The only difference here is the column name is up to the minute if the rollups is per minute. If it is per hour, then column name is up to the hour. And these are the counter column families. And we also track the individual order where we have order ID as a row key, and the column names are timestamp and the status of the order. So I'll go a little bit more about the fraud detection. So fraud detection is really a central piece of all our eBay platform. So whatever page you access on eBay, whenever you do a buying, selling, everything is first goes to the fraud detection. And as I mentioned earlier, we take these business events and do some real-time insights and use it for fraud detection. Now, in addition, whenever you sign into eBay, we collect some information about user and store it into Cassandra, like machine ID, internet environment, or some beacon data which used to know whether you are coming behind the proxy or not. We also have Oracle environment for fraud detection, and a lot of various other information is stored there. Periodically, we pull Cassandra and Oracle information into a long-term storage as a service, which is Atmos-based, and use that to do some machine learning and train the models. Because this fraud detection is ultimately based on the models and the training and some real-time insights. So quick glimpse on this sign-in data that we capture. It's straightforward like key value pairs, user ID, machine, and event types. The interesting thing to note here is we cannot use this column family to move data to the storage as a service, because we cannot do the easy ren scan on the row keys, because nobody use order preserving partitioner. So we keep another column family which aggregates data by hour. And as you can see here, one row has all 1 hour worth of data. So whenever you want to pull, we can just make 24 row key calls for pulling 1 day's worth of data. So metrics collection for monitoring and alerting. So we have something based on common RRD tool, round robin database, and it has famous scalability issues and flexibility issues. So we are trying out Cassandra for this use case. So we have thousands of servers running in production. Each has an agent deployed, and this agent collects CPU, memory, disk usage, and send it to centralized set of servers through HTTP transport. Currently, these servers are based on a highly scalable NIO library called Natty. And we also run in-memory grid from called Hazelcast for doing in-memory rollups before we write to Cassandra. Well, you can also use Cassandra distributed counter instead of doing in-memory rollups. This is mainly to offload some traffic because it was really high traffic. And we may change it in the future also. And these reports are shown in real time for monitoring and alerting. So data model is kind of similar to other data models in previous slides. The only difference here is it's more generic, and here the row key is namespace, metric, and scope. And namespace can be like server.ebay.com, metric can be disk or CPU, scope can be which partition of the disk you are tracking. And the column name is timestamp, and the actual payload is stored. So this is a raw data for each granular data points. And we keep these different samples and rollups for different time intervals. The other column family has same row key. The only difference here is the column name, where we have the interval period. If it is a 60 minutes, then the time will be up to the hour. If it is 1 minute, then time will be up to the minute. So these are just like various ways we are storing depending on the use case. There is no like standard way you should be doing it. It really depends on the use case. So you may see like similar kind of things we are trying to do, but we have to do it in a different ways because query patterns are different. So test-based recommendation system. So eBay is really a big graph of buyers, sellers, and items. And we try to model this graph in Cassandra and use this data to do recommendation on site. So I first going to data model for this use case. So our test graph is stored in main 2 column families called item ages and user ages. Here again the same idea. We have a row key of item ID, and the column name is composite of time, age type, which is sell, bid, or buy, or anything else, and the user ID. And what this represents is really represents the age from item to the user, and at what time the activity happened, and the type of the activity. We store the same information in the reverse order. It's the same data duplicated. So user ID becomes row key, and item ID is part of a composite column. And the test vector is kind of a test profile of the user, and we keep it as a static column family like item ID and the test vector for item and the user. So we already have more than 50 billion ages in production, more than 600 million writes, more than 3 billion reads, and more than 30 terabytes of data in SSD. So we use SSD for this use case because as you can see, there are 3 billion reads. And I'll show you where this read happens. So system overview for recommendation system. So as I mentioned earlier, all the events goes into the business event stream, and we get this item purchase event. And what recommendation system does is it write the purchase age in those 2 column families, item age and the user age. And it reads the other ages for the same user and item from those 2 column families. So that's where a lot of read happens, because it's real-time reads whenever buyer and purchase items. So depending on this past history of the user and item, we do some algorithm and figure out what are the user test profile and update the test vector. Now, this keeps happening as you do activity on site, and we keep collecting the test graph and updating the test vector. So whenever recommendation requests come from the site, it goes to this recommendation system, and recommendation system reads this test vector and shows item like similar to or what user might be interested on item from the other people may have liked. Well, I'm not going to go detail about the this test vector computation. There is a presentation in the last Cassandra Summit at New York. You can find out more information if you're interested to know the algorithm and how we compute the test vector. So real-time personalization data service. So here we keep track of your session information as you do a lot of activities on site, and use this information to show again some personalized behavior on site. So for example, if you perform search using some keywords, we use this kind of information to show you some personalized experience when you visit different pages on site. So this system is there actually for quite some time, and this is acting as our server-side cookie management, because we keep track of a lot of session information. We cannot store all this information in the client browser. Even we run out of number of cookies. So this helps us to manage all the cookie information on the server side. So Personalization data service is platform service and being accessed by many various application SOA services. And underneath it stores data in in-memory grid of MySQL and now XMP database. This cache really it's homegrown built write-back cache. So all reads and writes goes to that cache, and data is flushed to the Oracle persistent tier every few minutes. So we also have other part where we want to pull data from data warehouse, which has some user profile information, and serve it to the personalization data service. So that's where we are using Cassandra, and this use case will have lots of periodic writes as well as lots of reads from the site. So we will see how this use case is not wired on yet. We are going out maybe within 2-3 weeks. So we'll see how the Cassandra read performance works on this, and if not, we may go with SSD or add some memory tier on top of it. So data model is quite simple. It has static column families. And what we have learned here is make sure your column name is small, because it's repeated with each of your column value. If your column family is static. What I mean by static here is you are not storing the actual data in the column name. If you store actual data in column name, then there is no harm keeping like big or small. But if it is static column name, then keep it small, because it may even double or triple your storage need if your column value is significantly small. And don't overload one column family with all the data. So try to split your hot data and cold data in different column families. And even if it may help if you try to split heavily read attributes and kind of low traffic attributes. This helps Cassandra to basically your OS to keep data in cache. We also do the manual sharding of these column families, because manual sharding can help the compaction run faster. It's better than the multi-threaded compaction. But it's a lot of overhead, so you got to decide depending on the use case. So social signal use case. So if you have noticed this like, own, and want buttons on the eBay site, these buttons are served by Cassandra, and we collect this information and do some real-time analysis on this. So there is another page to see things that you have liked so far, own and want. This whole page is also served by Cassandra. So I've covered this use case in a very much depth with whatever different challenges that we have faced. If you're interested, you can go to the last year Cassandra Summit. So quickly on the multi-datacenter deployment. So whenever we get requests from a user, the request can end up to any data center. We don't have any data center affinity. And also we don't have any affinity from load balancer to the application server, because this cannot scale very easy. Now, Cassandra ring spans multiple data centers, and the beauty here is our application server only talks with local Cassandra ring nodes. Application server never has to go across the data center. This is the biggest advantage we are getting because Cassandra is a peer-to-peer multi-master architecture. You can have multiple replicas taking write for the same data set. So we use NTS topology. Replication factor and the consistency level varies depending on the use case. So even if we can have multiple replicas in Cassandra, we take periodic backup of this data, because what if somebody goes and drop the column family, like some human error or some software bugs? So we also have some use cases doing analytics on the Cassandra ring. This gives us some near real-time analytics because we don't have to move data, ETL, and other things. So quick lessons and the best practices. So one size doesn't fit all. So I would recommend not to use like one database for all the use cases. Maybe it depends, it's a cost also, but you have to find the right balance. We also don't want to get a big zoo of databases, but also at the same time, we don't want to have one database for everything. So choose proper replication factor and consistency level. I've not covered much in this presentation, but I've covered in the last presentation. So make sure your consistency level and the replication factor is right, because it alters your latency, availability, durability, consistency, even cost. Cassandra supports tunable consistency, but remember the strong consistency is not free, because you may have to give up some latency and even availability. So I've shown so many data models in the slides. So my recommendation is just don't go and copy this data model, because there are so many ways to model data in Cassandra, and the best way really depends on your use case and query patterns. So denormalize and duplicate for re-performance. That's kind of a thumb rule in Cassandra, but don't denormalize if you don't need to denormalize, because it comes with a lot of disadvantages of the denormalization if you are updating data quite often. So there is one presentation I have done in a Cassandra meetup. If you're interested on more on data modeling best practices, I would recommend to go through that one. I think that's it I have. And actually, we are hiring. So if you're interested, talk with me afterwards. I can take more questions. Yeah, please.
Yeah, for that logging infrastructure that you had there, and it's going to the, I don't know, that cluster with the Hazelcast, data grid. Is your logging going right to Cassandra for durability, or is it getting processed first and then,
Yeah, so currently it's very early phase right now, and it's right now directly sent to the centralized server through HTTP transport. We may change it in the future, because we have seen definitely if we can use some Flume or something, and we already have some use cases from Red Lizard. They are using Flume to transfer this data.
Okay, thank you.